Okay. Eventually, I'm going to get this thing figured out to where I start on time. Yesterday was interesting. I was here the whole time, and then I didn't realize didn't realize I wasn't on the actual screen. And then today I had some stuff going on, and I'm slowly figuring this thing out. I appreciate everybody's patience. I hope everybody's finding their day starting off well. And thanks for joining me. If you're listening or if you're watching, hopefully we have a good little discussion today. We're going to be talking about perennial ryegrass. Yesterday, I said I would talk about potassium with Bermuda grass. And I'll get to that paper. It'll probably be on Tuesday of next week. It's a paper I definitely want to make sure I cover, because it actually the Bermuda grass paper is one of the more exhaustive papers on Bermuda grass and potassium. It was conducted in Florida, but I came across I didn't come across. I was scanning through my papers, and I realized there's one here that may be a little bit more appropriate or pertinent to what we've been going over, and because it actually shows a value or a benefit to applying potassium with cold resistance. Yesterday there was some most of what I showed yesterday was Dr. Miller's study, I believe it was. We're going over yesterday. I don't recall now. But there's not a clear-cut case where potassium was consistently showing a benefit. And so I don't want that to be, I don't want everybody to go away with the concept that potassium is never good and you never want to apply it. There's never going to be a response to it. I would say in general, you're probably going to be saving a lot of money if you start there, but that's not fair. There are some benefits to applying potassium, and they're just not consistent, and they're not. It's not very common. So that's what I wanted to go over today. So we're going to talk about the effects of nitrogen and potassium, fertilization on perennial ryegrass cold tolerance during deacclimation in late winter and early spring. So the way this is going with the channel now titled Turfgrass Epistemology. Well, first of all, what is that? It's the study of knowledge. Epistemology is the study of knowledge, essentially. So if you were to kind of sum it up, it was like, I would say in Turfgrass, it's the concept of having confidence in knowing. How do we know what we know? So how do we know the BMPs are valid, or how do we know that applying potassium is going to result in whatever? How do we know that? So it's the study of knowledge. And so I thought it made sense for this channel. So it's going to be called Turfgrass Epistemology. And how do we know is by usually through the scientific literature. It's usually through scientists going through. Hey, Randy, Chad, and Aldo, I see you guys in the chat. So will I cover the other pyramid soon? Actually, yesterday was the pyramid. So Randy, 4 p.m. Where are you at? Asia somewhere? Australia? It's the study of no BS. So yeah, I did cover the pyramid. That's what it was yesterday. I covered the water, light, temperature, the risk pyramid yesterday, Randy. If you weren't able to join us, then you can go back and watch that video. On Monday, we're going to be going over another pyramid called the hierarchy of evidence with the Dean of Research. So Monday at 9:30, and I better not be late. So the last 2 days, I haven't quite figured this whole thing out. I end up showing up late. So I'm getting it figured out. So she ain't gonna wait on me. So if I'm not there getting things going, I'm gonna be soloing it on Monday. So I'll do everything I can to make sure this thing is running and on time, and trying to figure out how to get things started. And apparently I got to start earlier because I don't know all this IT stuff. But anyway, so epistemology is a study of knowledge. How do we know what we know? And we know this through the scientific literature and people doing research, and then through that we develop BMPs, and they kind of get communicated down the line to managers and homeowners and things like that. So that's why I'm going over so many papers. I want to make sure we have an understanding, a basic knowledge of literature and how to find it, and all these things. So as I usually start with these, I want to make sure everybody understands how I find these papers. This paper is not as easily acquired as some of the other papers, because the other papers are in Crop Science or Agronomy Journal or something like that. This paper you can find, I found it through the literature in articles. So in articles that talk about potassium and that talk about turfgrass, they'll cite other people's work, and then through there you can start going down the chain of various publications on potassium. And this one is done by Scott. I don't know D.E. Webster, unfortunately. I'm not sure if that was a grad student or professor. I apologize for that. But Scott Ebdon is so ridiculously intelligent. He's super nice, super kind guy, and man, he is so smart with statistics. It makes me feel like I'm in kindergarten when I'm around him doing statistics. So this is one of his papers he did a few years ago, and he published it in Hort Science. But the way you can find this is looking through the literature of other papers, and then going to Google and searching, or going to Turfgrass information file, and searching for the title that you found in some other paper. So for example, in this paper, he cites a lot of articles, and you can go down here and you can find, I can't highlight in this article for some reason. You can find all these various articles that he cited, and then you can go look those articles up. So just copy and paste this into Google, and usually they'll pop up. If they don't, then go to Google Scholar or go to TGIF, Turfgrass information file, and you can find these various articles. So for example, if you wanted this article down here by White, cold acclimation and deacclimation in cool season grasses. I mean, there's a citation here. This was actually at a proceeding at a conference, but you can go find this information that way. That's a good way to find information. It ends up being, because it's always citing publications in the past, you end up kind of going backwards in time. If you want to find some of the more current literature, you need to do a little bit more of a current search. But anyway, this particular article is in Hort Science. Now, Hort Science is a part of the American Society of Horticultural Sciences. So if I can go to the internet, and see if I can make this work over here, and I cannot, apparently. Well, so we'll just stay with the PDF. You can go to ASHS, American Society of Horticultural Sciences.org, and you can search their journals. So that's where this is found. Hort Science is where this article is published. Okay, so that's how I would go about finding it. The pyramid. The other one that begins with drainage, brown one, you show it on the Grass Factor show. I'll look it up. I'll go back and watch that video, Randy. I don't particularly recall that, but I'll look it up, and if it jogs my memory, I'll go over it. Okay, so effects of nitrogen potassium fertilization on perennial ryegrass cold tolerance. Now, in this particular article, I can't highlight anything. I don't know why. So I put arrows, and I want to kind of go through some of the key points that I highlighted. So this is, again, we can read the abstract and get an idea of what he did and what he found, they found. And you'll find in here, if you don't want to buy the article or join the associations or track the article down, you can read through here and you can see some of the highlights. And alternatively, similar K fertilization and soil K levels combined with high rates of nitrogen, they give the rates, increased freeze stress and low temperature fungi. So it increased the stress at these, But at N rates routinely applied to perennial ryegrass, higher soil extractable K beyond those levels currently recommended for optimum shoot growth could provide some benefit in enhancing cold hardiness. Late fall applications of N did not appear to increase potential for wind injury. So what he's saying here is in the abstract is you can see that this is an odd paper because what you find at one N rate doesn't happen at another N rate, okay? So if you say, I'm just going to go apply potassium at 0 N, what these authors will find is that X happens. If you go apply potassium at 2 pounds of N, something else happens. So that you can find that in the abstract, okay? So that's what he's saying here at the end. So we're going to go through here, and it's very, this article is not the easiest one to interpret because there's a lot of really complex statistics in it. But I'll do my best to kind of bring it to a level that it's practical, I guess is the way to say it. I wanted to highlight a few things in the introduction. Remember, the introduction of all papers is the setting. You're trying to provide a justification for the work. You're trying to describe what has happened in the past literature, what some researchers have found, and then justify your objective or your hypothesis. So why are we even doing this? We're doing this because there's an observation, there's a problem. This is what some people have done in the past. However, they didn't address this specific issue, or there's some unique thing about the question that we're asking that other people haven't really thoroughly investigated, and then therefore we're doing this work. That's what the introduction is designed to do. So there's a few things he highlighted or he mentioned here. So the first arrow says, research has shown that creeping bentgrass is one of the most tolerant cool season grasses to low temperatures, while perennial ryegrass is one of the most susceptible. Okay, so right there from the beginning, we have a context of what we're going to be looking at. They're looking at perennial ryegrass. It's a cool season grass. It's often overseeded in Bermuda grass, fairways or lawns occasionally. Not so much nowadays, but it has been. Occasionally you'll find a full stand of just perennial ryegrass. But they're differentiating between perennial ryegrass and creeping bentgrass. So what we're going to find is specific to perennial ryegrass. So please don't misinterpret these results as, Dr. Ebdon published a paper showing that applying potassium does increase cold tolerance. That's true, but it's specific to perennial ryegrass. So if you don't have perennial ryegrass, to go from perennial ryegrass to tall fescue or ryegrass to bluegrass, where it's still in the same sort of family of cool season grasses, is not a valid comparison. Okay. That's critical. And the same thing goes for warm season grasses, whether it's a putting green grass or a fairway grass, or whether it's, centipede grass or St. Augustine grass or whatever. They're all warm season grasses, but we need to make sure that we're understanding that we cannot go outside the boundaries of the parameters of the study too much. And granted, we do have to do some extrapolation. We do have to have a little bit of awareness that, yes, okay, it wasn't done on every single combination of soil and turf and every cool season. So we can do a little bit of extrapolation, but we can't go outside the boundaries very much. So in other words, what I'm saying is, take it for what it is on perennial ryegrass, but don't turn around and say, hey, I have tall fescue and I'm in New England, or I'm in the Pacific Northwest or wherever. And so I should be applying potassium too, because Dr. Ebdon said that potassium is useful. He said it's useful in his location for perennial ryegrass. If you have perennial ryegrass, say, and he's in Massachusetts, I think he's in Massachusetts. Yeah, Massachusetts. So if you have perennial ryegrass, say in New Jersey, then that might be relevant, okay? Or New Hampshire, then it might be useful to you. But if you have perennial ryegrass overseeded on fairways in Oklahoma, it might not be, okay? So keep that in mind, okay? So he starts that off by differentiating perennial ryegrass is the most susceptible, or is one of the most susceptible to to low temperature, okay? The biological explanation underlying low temperature injury is crown hydration, which increases with tissue in. So when you talk about cold hardiness, generally the consensus of specialists in this area are measuring the hydration of the crown of the plant. Okay. If it dries out and it desiccates, there's a good relationship between that occurring and winter kill. If it remains hydrated, if the crown remains hydrated throughout the winter, then the likelihood of winter kill greatly declines. Okay. So this is critical. A good piece of information to take with you is that it's the hydration that is critical, and that's oftentimes what people associate the application of potassium with increased tolerance of winter kill, even though in the literature it's certainly ambiguous. Sometimes you see it, sometimes you don't. Okay. Markland and Roberts found that tissue hydration levels decreased with increasing amounts of potassium. So in this particular study in 67, the hydration was going down with increased amounts of potassium. And I may pull that Markland and Roberts 67 paper to discuss it. But Herto and Troll, 1980, evaluated low temperature hardiness on perennial ryegrass using sand culture. They reported an inverse relationship between winter kill and water-soluble carbohydrate content and positive correlation between winter kill and tissue K levels, with the maximum tiller survival provided by a 2-to-1 N to K. So remember, we've been talking about N ratios in some of the past videos. And in this particular study in 1980, they found that where is it worded? Carbohydrate level and positive correlate. Okay. They found K levels with a maximum tiller survival. So maximum survival occurred with a 2-to-1 N to K in that study. Other studies find different things. Although Cook and Duff 74 reported tissue K contents ranging from 0.7 to 3% during the cold hardening period in tall fescue, no connection was detected between potassium nutrition and freeze tolerance in that study. So here's another study where there was no connection. Okay. Similarly, no relationship was observed with potassium and freeze tolerance of tall fescue and carbohydrate level from the Cook and Duff study in 76. So what he's saying, basically, he's setting the stage saying that there's been several studies published where there's really not much of a relationship between potassium and cold tolerance or freeze tolerance. Where there has been a benefit, it's been from a 2-to-1 application of nitrogen to potassium in those studies. Okay, that doesn't mean it's going to be the case in every study. There's actually publications showing greater amounts of potassium will result in a greater amount of winter tolerance. And that's what this study is going to show that I'm going through right now. Okay, let's keep going through the introduction. I just want to point out a few things. Beard and Reike, 66, reported that an N to K ratio of 2-to-1 provided maximum low temperature survival of Kentucky bluegrass and creeping bentgrass at all levels of N applied, from 0 to a very high level. Okay. Their results suggest that a balance of potassium that is 1/2 that of nitrogen is important for maximum cold hardiness rather than low N or high K. So we're going to show, or Dr. Ebdon's going to show in this paper, that that's not what happened in his case with perennial ryegrass. But he showed, 3 or 4 publications that either potassium didn't really have much of an effect, or when it did when it was applied at half the rate of nitrogen, when nitrogen was applied at the rates listed they showed. Okay. This is oftentimes why you'll see me, this is one reason why you'll see me harp on 2-to-1 N to K ratios if potassium is needed. Okay, most of the time it's 100% nitrogen. I don't see much value in applying potassium in most cases. But when potassium is needed, a 2-to-1 application is generally the most effective or most efficient in terms of dollars spent. So we're going to talk on Monday about the hierarchy of evidence. There's little pieces of paper. There's a paper here. There's a paper there that shows an indicator of 10-to-1. There's a paper there that shows an indicator 2-to-1. There's a paper that, and it sort of starts building. And that's how the epistemology of this is. That's how I become convinced that an N to K is probably a good starting place if potassium is deficient. In some cases, there's a little piece of literature that shows a 1-to-1. Okay, so that adds to my confidence on using a 1-to-1 in some cases. Okay, this is how we become knowledgeable and become convinced about what management practices to follow or not, by following the literature and following what other people have published. Okay, we'll talk about sometime about publishing and not publishing. I'm not too much concerned about what people, their opinions or their positions on issues if it's not published. Okay. I'm sort of an emotional robot. Okay. I see things black and white. There's good things and bad things to that approach. But if we're going to go down the roads of so-and-so saw this and the mathematics behind this makes sense or whatever, that's fine. Publish it. Okay. And then we can talk. Otherwise, everything's moving around. They're moving the goalposts. They're moving all the objectives. Publish it so we can have a critical conversation about it. We can have a meaningful conversation about what you did and how you did it. And then it's in the literature for eternity and we can talk about it. Okay. But if it hasn't been published, I don't know what you did. I don't know what you found. It's all hearsay to me. I mean, it needs to be published. Otherwise it's a hobby, as I've said before. Turfgrass science is a hobby unless you're publishing it. Okay, so at the end of every introduction, almost every introduction in today's publications, is the hypothesis or the objective. And that's what you see here. The objective of this study was to evaluate perennial ryegrass low temperature hardiness in response to nitrogen and potassium during deacclimation. So he's going to be doing this late in the winter. Okay, well, here's in late winter, and its effect on crown hydration, lethal freeze temperature, shoot growth, and shows all the various soil. Okay, So he's doing this late in the winter. He wants to know what is the effect on these various variables when we're applying nitrogen and potassium. So we're going to talk about fertilizer treatments. Fertilizer studies initiated at the University of Massachusetts. So we know it's perennial ryegrass. It's at the University of Massachusetts. Okay, and we know he started it in the year 2000, so 23 years ago. 15 NK combinations were applied to establish, and here's the grass, perennial ryegrass. So we know this is the exact cultivar perennial ryegrass that he used. We know it was conducted on a Handley silt loam, so we know the type of soil, and we know the extract that he used, which is a Morgan extract for potassium. Okay, so he's going through the materials and methods, explaining exactly what he did, so we can follow what he did, and we can repeat it if we need to, if we're interested. Other people can repeat it. Freeze stress sampling. We're going to talk about this just briefly. 4 plugs were removed from each plot for freeze stress evaluation. So in a previous study, Dr. Miller's study, he was looking at the rhizome, the below ground stem, if you want to call it that. And in this case, he's taking plugs. Okay. And he goes through the whole process of explaining exactly how he measured the freeze stress. Samples were taken during deacclimation phase. So he tells you when he collected them, and he goes through the whole process. Okay. We're going to skip through this. You can go through here and read this if you're interested in knowing more about exactly what he did. Okay. After temperature exposure, the plant material was removed from the freezer and assessed for survival as a percentage of viable green shoots. Okay, so that's how he measured the survival, basically. Survival is the percentage of viable green shoots. The temperature at which half the plant tissue that survived based on regrowth recovery was expressed as LT50. So oftentimes you'll see that survival is like what temperature resulted in death of half of the samples. Okay, freeze stress electrolyte leakage. This is a similar variable they measured in the Miller study, where leaves and roots were removed from plant samples. So in this case, he's looking at he removed the leaves and roots, leaving only the crowns. So 5 crown samples were placed. So the previous one we were talking about rhizomes. Now he's measuring crowns. So it's a little bit of a different measurement method than what was published by the Miller study. Okay, so we're looking at the same effect, freeze tolerance or winter hardness, whatever, but they're measuring it in a different way. So why is that important to you? Because if you come across this literature, you come across someone saying this, well, Miller found that and Scott and Ebdon found that. Well, yes, they're different. They measured them different. They're doing different grasses. So you have to contextualize everything to compare apples to apples. Okay, we're going to go through. We're actually going to come back and look at some of these graphs in a minute. Actually, we're going to do that now. I was hoping I could find a way to zoom in on this a little bit. I'm not sure if I can do this or not with my limited knowledge of stuff. So we're going to get to the results in discussion, see if I can figure out how to do this. Okay, that might be better. So predicted crown moisture content of perennial ryegrass during late winter. Okay, fertilizer, So here you're going to see the applications of nitrogen going up on this secondary x-axis, And here you're going to see the application of potassium going up on this x-axis here. And then on this, I predicted crown moisture. Okay. So he is predicting, remember, when the crown dries out is when the risk goes sky high in terms of winter death, winter kill. So we're looking at the combinations of products that will result in increased moisture in the crown. And we see as nitrogen goes up, we see the moisture kind of go up. It kind of goes up and then down. And as the potassium goes up with very little in, we see not much increase over here. Okay. But as the nitrogen goes up and the potassium goes up, we see an increase in crown moisture. So that's how you read this graph. We're going up in nitrogen and we're going up in potassium, and we see this increase in crown moisture. All right. So just the application of potassium alone doesn't look like it hardly did anything from 49, if I'm reading this correctly, from 49 to 441. We didn't see much change. So this is, in my opinion, a good piece of evidence to limit or eliminate 100% potassium applications on perennial ryegrass in Massachusetts if you're looking to increase crown moisture. Simply applying only potassium didn't do much. Applying potassium with nitrogen is where we saw the benefit. Okay, I hope that makes sense to everybody. We can read through all the details and all this stuff. I was trying to do this yesterday, but I was having some problem. Like, for some reason, I can't highlight anything in this particular PDF. I don't know why. I have highlights selected, but it's not letting me highlight. So you have to just follow my cursor around. And then we'll jump to the conclusions after the results. So here's the predicted lethal temperature, where 50% would be dead. And we actually find that a similar graph. The potassium with very low nitrogen, actually, as the potassium goes up, we see the temperature go down. In this particular case, the predicted lethal temperature, we want to go down, I guess. I mean, if I'm reading this correctly, we don't want a predicted lethal temperature of 0 degrees Celsius as opposed to -8. That means as soon as it freezes outside, it's lethal. So we would like a lower temperature to lower the lethal temperature down, so that ideally we would never reach that temperature. If it didn't get too cold, we wouldn't reach that and it wouldn't die. And so we see, so we see the potassium applications are reducing the lethal temperature from 11 or whatever this number is down to about 13. Okay. When we're adding nitrogen, we've seen the lethal temperature actually go up to about 9, I guess it is, 9.5. Okay. So that's the way to read that graph. Here's the actual temperature that occurred during that time. When we get to graphs or tables like this, you can go through here or you can read the results in the text. Okay. It's probably easier you can go through here and find all your comparisons if you want to look at it. But it's probably easier to read what the authors wrote, because they're going to write sort of the highlights. They're going to hit on the main points that occurred. Okay. But let's just kind of look what happens when you only apply nitrogen. Just for an example, shoot growth. 1 pound of nitrogen, remember 49 kilograms per hectare is 1 pound per year. So per year here, when you see year -1, that means per. So kilograms per hectare per year. 1 pound, we see the shoot growth was 1 gram per meter, 1 gram per meter squared per day. Okay. And we add 3 pounds and we see 3. We add whatever this is, 5 pounds, or I can't do the math that quick in my head. We show the shoot growth continue to increase with increased nitrogen, of course. Tissue K goes from 2.9% or 29.6 grams per kilogram, goes up to 3.4% with nitrogen. So we're adding nitrogen, we're increasing the shoot growth, and we're increasing the concentration in the leaf tissue. We're decreasing the K. Now you can go back and read the materials and methods and find whether he removed the clippings or put the clippings back on the plots. I don't really remember. But we're adding nitrogen higher and higher and higher, and we're depleting the soil K. Okay. And then we have snow mold percentage. We see the snow mold go from about 50% to 62%, which is significant biologically and statistically. When you see this LSD minus or negative, 0.05. What this means is the least significant difference at the 5% confidence level. And when you see the values, this 6.5 is the least significant difference. So if you add 6.5 to 49.8, if it's greater, if that summation is greater than any other number, then the numbers are the same. So 49 and 62 is roughly 12. 12 is greater than 6.5, and so 441 and 49 are different. So in other words, 441 resulted in greater snow mold than 49. 1 pound resulted in less. Okay, that's how to read that. If you just apply potassium, so if you're just going out and you're just applying potassium and this is looking at winter kill, but if you're looking at just applying potassium for snow mold on perennial ryegrass in Massachusetts, we see what happens. We do see an increase with growth from application of potassium. That's very rare to see that, okay? But you do see an increase. It's 0.5 difference, and we see 0.4 is the least significant difference. So these are significant increases, the 245 and the 441. Tissue K, we see the tissue K go up, soil K went up. The snow mold also went up. Okay, so in this case, the application of potassium to perennial ryegrass, solely potassium, resulted in an increase in shoot growth slightly, an increase in tissue K, I don't know if it's biologically significant or not, but it's statistically, an increase in soil K, and an increase in disease. Okay, this is consistent in many pieces of literature. Dr. Soldot's finding that in Wisconsin. I think Dr. Woods found that in his PhD research, where the application of potassium occasionally on cool season grasses can result in increases in some diseases, usually snow mold. Okay, that can happen if you're only applying potassium. All right, and then here's all the various combinations that we can go through, and there's a lot on here. But I want to point out that people think, oh, I'm going to apply potassium to reduce disease or increase stress resistance. So, we're finding that when you're just applying potassium, we've found this, we've known this for years. When you're just applying potassium, you're increasing the risk of disease occurrence. Okay, so that's critical to understand. Now, when you apply those same rates, let's take these three rates, which are right here, with 1 pound of N. Okay, so you apply 1 pound of N, 49, and 1 pound of K. Well, it goes from 45 to 55 to 48. The least significant difference is 11 down here. So 11, these are statistically the same, and these are statistically the same. So we didn't see an increase in snow mold when it's accompanied when the potassium is accompanied by 1 pound of N. Okay. The same thing goes here, 147, and you have the same rates of K going up. 147, 56, 50, 58. We don't see an increase of microdocium when we're applying, 3 pounds of N. So you gotta read these things sort of, critically to really understand. Oh, don't apply any potassium because it's increasing snow mold on perennial ryegrass. It did when it was applied by itself, but not when it was applied with a little bit of nitrogen. Now, when you go to the higher end, the high rates of nitrogen, so we're up here in the 343. Someone can do that math for me real quick. I always forget these. 343 divided by 49, 7 pounds of N. So when you're up here in 343, 7 pounds of N, you go from 48% to 62%. That is resulting in an increase in disease. The application of potassium with nitrogen at that 7 pound rate. Okay. And the same thing goes for the application of potassium at the 441. What is 441 divided by 49? 9 pound rate. So at these very high rates of nitrogen, potassium is exacerbating disease, snow mold on perennial ryegrass. Okay. Critical to understand that. Don't apply it by itself. Don't apply it with high rates of nitrogen. Apply it with a little bit of nitrogen and you're okay. Okay. Okay, electrolyte leachage predicted of cold tolerance was affected by K interaction with N in ways different from actual whole plant survival. For example, here it's the same thing. So with the 1 pound of with nitrogen applied at 1 pound, increasing levels of K significantly decreased predicted cold hardiness. Okay, so the potassium applied with a little bit of N decreased, and that's from the figure 4, which was right here. Okay, so predicted lethal temperature, and we see nitrogen going up, potassium going up, and we see the predicted lethal temperature over here. Actually, I think that was opposite over here. So, electrolyte leakage. Okay, electrolyte leakage. Okay, so you can read through there and find what that means. Predicted shoot growth rate. So if you're looking at shoot growth rate as affected by N, of course, N goes up, shoot growth goes up. As K goes up with little N, we don't see much going on, but we do see some effect as the nitrogen rates. Well, I guess they did find that the shoot growth rate did go up with a little bit of nitrogen was applied. Predicted blight. So this is percent of the plot affected by the disease. And you'll see how those affect. So that's how to read this. The nitrogen is going up. The disease is going slightly up. With a little bit of nitrogen, you see not a whole lot happen with the disease, but at the high rates of nitrogen, as the potassium goes up, that's when you see the disease really start to increase. So this is a good graph to understand if you're looking at reducing disease occurrence. Straight up just potassium with little to no nitrogen doesn't do much in terms of increasing it. But when you're applying at a high rates of nitrogen, you do see an increase with disease. I'm not going to go into all this, but basically this is the statistical models used, the linear, quadratic, cubic, and quartic models. And what he's doing here is he's just determining which model best interprets the data, best explains it. So we're going to go through here. Furthermore, the luxury consumption of potassium that was observed is the most likely explanation for superior cold hardiness afforded by the 49 to 441 that a treatment combination when compared to this one. So they didn't determine whether or not luxury consumption was the source of this result. So you want to be real careful when it says the most likely or the most plausible. When you're reading papers and it says the most plausible explanation is probably this. Well, could be, could not be. So you want to be real careful when you hear verbs like that or words like that, plausible, or the most likely explanation could be this. It might be, but he's really hypothesizing that here. He's not concluding that. Okay. Let's see here. The higher leaf growth rate, the higher leaf. Let's see. Okay, so I'm just going to go through here to get to the end. So N and K for maximum cold survival. So let's just cut to the end. N and K for maximum cold survival on perennial ryegrass in Massachusetts in late winter. Okay. Maximum low temperature tolerance was associated with nitrogen applied at 1 pound of N per year to moderate to 147. So that's 3 pounds, 1 to 3 pounds. In combination with annual K rates ranging from 5 to 9 pounds. So in this case, they're saying 1 to 3 pounds of N with 5 to 9 pounds of K is what where maximum low temperature tolerance was connected to that. So this is contrary to a lot of the other literature where we're showing. So this is basically a 1 to 2 or around that ratio. Of N to K. And so this is very different from previous literature where they were showing 2 to 1s or 1 to 1s or something, much lower amounts of potassium. So, but remember, this is on perennial ryegrass. All right. So let's go to the next point I wanted to make. However, the data suggests that over-fertilization with water-soluble nitrogen in the fall, so over-fertilization, meaning 2 pounds or 1 pound in September and October, in combination with 5 pounds of K, and in combination with K and higher, so 5 pounds of K or higher, may increase free stress injury or low temperature disease. Okay, so let me kind of make sense of that. He's not talking about 5 pounds of K or higher increasing free stress injury. He's talking about 5 pounds of K or higher increasing it when it's accompanied with water soluble nitrogen being over-fertilized with. Okay, so when you're over-fertilizing with nitrogen, then those potassium levels can be detrimental. It's critical to decipher that a little bit. Okay, it's not that they're resulting in it. It's that when it's applied, when you're going outside the BMPs, when you're applying nitrogen at a rate that exceeds what we recommend, then you're going to have some issues, which is one reason why we have the BMPs done the way they're done, because we do these crazy rates of 10 pounds a K and 10 pounds a N and 15 pound. We do these really, really crazy rates to see what happens to these high ends. And so we know the safety factor. We know what we're recommending is within reasonable safety limits. Okay, so high rates of nitrogen and high rates of potassium may result in increases in free stress injury. Okay, and low temperature disease. No shoot growth response in perennial ryegrass was observed in this study with increasing soil exchangeable K at N rates of 5 pounds or lower. Okay, so the shoot growth rate did not increase with increasing soil exchangeable potassium whenever the nitrogen was applied at 5 pounds or lower. Okay, so if you're thinking you're going to increase shoot rate at these normal nitrogen applications, say 1, 2, 3, 4 pounds in, you're applying potassium. It's not usually. They didn't find that in this study, I guess. So at these nitrogen rates, soil exchangeable potassium of 135 milligrams per kilogram and possibly lower were more than adequate for maintaining optimal shoot growth. So remember, they did the Morgan extract. So you might be familiar with Malix and these things. Using the Morgan on perennial ryegrass, they've concluded that the Morgan extracted potassium of 135, and like I said, they even say possibly lower, or more than adequate for maintaining optimal shoot growth. So there's a little bit of a critical limit for Morgan on potassium on perennial ryegrass. However, maximum cold hardiness was achieved at low to moderate nitrogen rates. Okay, so high rates of nitrogen don't help. It's the low rates of nitrogen where the maximum cold hardiness was achieved when it was fertilized with potassium at 5 to, I always forget, what was that, 9 pounds? I've done it twice now already and I still can't remember. Yeah, 5 to 9 pounds. Okay, which corresponded to soil extractable K levels of 200 to 260. So they're saying that 135 is reasonable and provides adequate for maintaining optimum shoot growth. But the maximum cold hardiness was associated with a higher level of K in the soil. Okay. Last thing is, let's see, at these high rates, at these high nitrogen rates, winter injuries from free stress and low temperature fungi increased with potassium fertilization at soil exchangeable levels of 125 and higher. Okay, these results indicate at low to moderate nitrogen rates, higher soil extractable K beyond those levels typically recommended for optimal shoot growth may provide some benefit in enhancing perennial ryegrass cold tolerance. So that's the take-home message. Okay, low to moderate N rates with high amounts of potassium on this grass resulted in increased winter hardiness and cold tolerance. Okay, that's not normally the case in most of the literature, but here's a piece that is, contrary to what I've been talking about in the last video or two. Okay, so please keep that in mind. Just because Travis Shattuck said it, or he showed it on his YouTube channel or whatever, that's what I'm going over. I didn't say it. I'm going over what the author said. Please be aware. I'm just going over the literature. But you have to keep things confined to the boundaries of the study. Keep your convictions and your beliefs confined to those boundaries. I know it's like we did it from 0 nitrogen to 3 pounds of nitrogen. We didn't do 4 pounds of nitrogen, but 4 pounds probably does that. You want to go a little bit outside that boundary. You can't do that in science. Okay, you got to stay within those boundaries. We don't know what's going to happen on the other side of that boundary. Okay, we don't know what's going to, so in this case, it's perennial ryegrass. We don't know what's going to happen with tall fescue in Massachusetts. He didn't publish that. Okay, we don't, well, it's cool season grass, so it's all the same. No, it's not the same. Okay, So please be mindful of that, is that, you know, try to keep your convictions limited to the amount of evidence that supports that. And the evidence on these papers are strictly confined to what that paper did. Okay. I think that might be one of the take home messages I'd like people to go away with. Okay. Stay within your boundaries. And when you go outside those boundaries, sometimes it's okay, but you're starting to really alter and change the confidence level. All right. The last thing, we're done. So the last thing is, I'll be off tomorrow. Monday morning, I'll have the dean on at 9:30 a.m. On Tuesday, I'll go over the potassium paper with Bermuda. If you want to meet with me or talk with me, you can always go to my website, or the website calendly.com and /Travis Shaddix, and you can set up meetings with me and go over whatever you want to go over with in your program. Well, hopefully it's soil and fertility related. I don't know much about pests and so forth, but I really appreciate everybody for showing up. Leave a comment if you want to hear something you have some particular interest you want me to go over. I'll do my best to cover that in a future video. For that, thanks, ladies and gentlemen, for coming by. We'll see you next time.